Welcome to Mathematics Educators Workshop at Home. Today we are looking at the concept of algebraic graphs with the grade 12s. In our well-known question, how well can we teach algebraic graphs to the grade 12s? So let's go. We're firstly going to do a revision of all the algebraic graphs that learners did in their lower grade up until grade. First graphs that we're going to start with the linear graphs, and we do the rest of them. So let's start. I've always thought that the best way to do a revision of algebraic graphs in grade 12 is to draw up a worksheet of this nature, because believe you me, you do not have all the time to revise a set of graphs like I did here. This day you're revising straight line, you're revising parabola, or you need to plan a structured worksheet that will allow you to go through all these functions in a short space of time. So let's look at the first column that talks about straight line graphs. Now, if you look at the information that I just wrote above this dotted line, this is the standard form of the algebraic view of the straight line graphs. The standard form of the algebraic view of the straight line graph. Well, different variables are used. The first equation that I wrote there is y is equals to mx. And I said y is equals to ax. I'm saying y is equals to mx because I'm well aware that the variable m has been used in many cases, many other concepts like in geometry, that it represents the gradient of the straight line. So that a, it represents the gradient of the straight line. So the graph y is equal to ax. It is the straight line graph that passes through the origin. Now, this is the graph that goes through the origin like that. But the graph that I drew here, it is the graph of y is equal to mx with the gradient that is positive. It has a positive gradient, therefore it is an increasing graph. Now, what happens if the gradient is a number less than 0? So the graph is a decreasing graph. It is a straight line graph that passes through the origin point like that. It is my belief that in grade 11, all learners, they discussed the concept of increasing and decreasing element of a graph. When we say a graph is increasing, what do we mean? We are talking about the relationship between the function values and the input. So I'm just going to put some few numbers on the axis. Suppose this is -2, -1, 0, 1, 2. Right? Now, I'm going to start with the function here that has a positive gradient. When the value of x is -2 here, the value of y is -2. When the value of x is -1, the value of y is -1. When the value of x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 2. Now, if I am moving from -1 all the way to +2 in the horizontal direction, the values of x, they are increasing. Now, what is happening to the values of y as I move along that line? The values of y, they are also increasing. The first value of y we had was -2, followed by -1, followed by 0, followed by 1, followed by 2. These values, they are increasing. So we say when the values of x increases and the function values increases, that function, it is an increasing function. Now, if you compare the graph with the negative gradient, let's see. Let me change the color. When the value of x is -2, the value of y is 2. When the value of x is -1, y is +1. When x is 0, y is 1. When x is 1, y is -1. When x is 2, y is -2. So the values of x, they are increasing, going from left to right. But the values of y, they are dropping. So the first value we had here when x was -2, it was 2. When the value of x is -1, the value has increased from -2 to -1, but the value of y dropped from 2 to 1. Now it is at 0 and 0. When x is 0, x has increased from -1, but the y has dropped from 1 to 0. When x is 1, the value of x has increased from 0 to 1, but x has dropped from 0 to -1. So this graph here, it is decreasing, and that one is increasing. So that is also a very important element of discussing the impact of A in the linear graphs. Now, I'm now going to sketch, as the second instruction there says, sketch the graphs. The instruction says sketch the function of f of x is equal to 2x. So that kind of a graph, it is a straight line graph with a gradient, with a positive gradient. Therefore, that line, it is an increasing straight line graph that is passing through the origin in that fashion. Now, I'm simply going to identify a point on the graph. I pick the value of x is 3. Now, if x is 3, that will be 3 times 2 is 6. So the coordinate of this point is 3 and 6. The other graph that we have is a negative graph. So this graph goes like that. It is a decreasing graph. Now, once it's drawn like that, it is also passing through the origin. I simply pick a point. Let me pick a point up there. Say the value of x is -1. Therefore, the value of y is 3. I've sketched those graphs. My assumption is that the learners in grade 12, they did all these graphs, as in they wrote the exams based on all these graphs in the lower grade. So they know the behavior of these graphs, the nature of these graphs. So there's no need for us to be investigating the nature of these graphs. Remember that the investigation is done so that we can understand the nature of these graphs. Because when you are asked to sketch, you can only sketch something that you know. You need specific critical point that you put, and then you draw the graph. Let us look at column number 2, which talks about the quadratic graphs. Now, just above the line, I put all forms of the standard form that we can have regarding the parabola. The first one is ax squared. This is the parabola graph that is sitting at the origin. Depending on the value of a, if the value of a is a positive number, I know that the graph is increasing. We say, with the language of grade 10, we say it is a smiley face. When a, it is less than 0, meaning a is negative, we say it has a sad face. The graph is facing down. Now, let us now go and look at all the other standard forms that are given here. So, what are these standard forms? These are the algebraic views of the parabola. Now, these algebraic views, they've got information that you can read from these equations that represent the graphical information. There is a graphical information I can read from the algebraic view of this parabola graphs. When it is written in this format, as ax squared, I know that the turning point is 0 and 0. Now, depending on the value of a, it is either a sad face or a smiley face. The second equation, y is equals to ax squared plus q. Ax squared plus q. This is the same graph that we had above there, but the value of q shift the graph up or down. So that has the effect of vertical shift. When you look at the third equation, this represents a parabola that has been transformed in both directions, vertical and horizontal. Now, I'm going to start with the second equation going down. If you look at all these equations, the graphical information we can read here is this one has a turning point at 0 and 0. This one, the second one, has a turning point at the 0 and q. Why? Because the q shifts the graph up or down, but the graph is not shifted horizontally. So the value of x of the turning point remains 0. When you look at the y is equal to ax squared plus bx plus c, the value of c, it is the y-intercept of this graph. When you look at the second last question, the second last equation says t of x is equal to a into x minus x1 into x minus x2. So the x1 and the x2, they are the roots of the equation. Therefore, they represent the x-intercept of this graph. And the last one here, a into x minus p plus q, the value of p and q represent the coordinate of the turning point. So the turning point, it is basically p and q. So this is the graphical information that we can read from those specific algebraic format of the graph. So I'm going to follow the instruction which says sketch the graphs. So we're going to sketch the graph of f of x is equal to 2x. And when it's just like that, we said the graph is sitting at the origin. The value of a is positive, so it is a smiley face. So the graph goes like that. Now, I simply pick a point on the graph. So this will be, if I pick x is 2, therefore y is equals to 2 squared is 4 times 2 is 8. So the coordinate of that point is that. Now, the next question, what is given there is the same functions, 2x squared, but then it indicates that it has been shifted 1 unit up. So is this graph shifted 1 unit up? So simply move every important point 1 unit up. This is 0 and 0. When I shift it 1 unit up, it goes to 1 and 0. This point here is 2 and 8. 1 unit up, it goes to 2 and 1. So the graph goes like that. So this is the parabola. So this is the parabola G and this is the parabola F. So please, it is also important to note those names because the names, they are there for us to be able to identify which graph is which. So this one is a positive graph. So this is F and that is G. Now let us look at the rational graphs, the hyperbola. The standard forms that are given there, these are the standard forms that the learners learned in the previous grade. The first one, they did it in grade 10. The first two they did in grade 10, that is the parent graph, y is equals to a over x. And then this is a parent graph including a vertical shift. Now, when you go to the last one, is a vertical shift and a horizontal shift. But this graph has other important elements that we must talk about. There is what we call the asymptote. The asymptotes in this graph. These are the lines or the boundary lines for which the graph should not pass through in this Cartesian plane. Now, what are those boundaries? From the graph here, we can already see that x is not equals to 0. So that is the first line. So the equation of the line x is equals to 0. It is the y-axis. So this is the y-axis. The equation of this line is the line x is equals to 0. So the graph is not going to cross that line. The other asymptote, it is the x-axis, which the equation of the x-axis is the line y is equals to 0. These are the asymptotes of this graph. Now, for example, if you are looking at the graph y is equals to a over x, and a is a number smaller than 0, meaning it's a is a negative number. So the graph is going to be found in the second quadrant and the fourth quadrant. Now, when you're looking at this graph, these two pieces, they are absolutely the same, but they are facing different directions. Basically, what's happening is that these two graphs, they are reflections of each other. So this graph here is a reflection of this line about the line y is equals to x. The line y is equals to x. This is the reflection line of this graph. They're called symmetrical lines, reflection lines, mirror lines. If you reflect this piece about the line y is equals to x, it gives you this piece that is down here. But this is not the only reflection line this graph has. It also has a reflection line that is the line y is equals to negative x. And I'm going to use points to indicate such a reflection. Now, starting with the reflection of the line y is equals to x. So this point here is negative 1 and 2. When this graph gets to be reflected about the line y is equals to x, the point there, the image of that point becomes 2 and negative 1. So that is what is happening. The very same point here, it also gets to be reflected about the line y is equals to negative x, and it comes this side. Now, when it gets this side, the coordinate of this point becomes negative 2 and 1. So these are the two reflection lines that we must talk about. So I'm just going to put this in order without these graphs. Let me just underline here so we can put them here. We said the equation has the asymptote, which is x is equal to 0 or y is equal to 0. It also has the reflection line or the mirror line or the symmetrical lines where the equation are x is equals to y is equals to x or y is equals to negative x. So these are the two symmetrical lines that the graphs of part of hyperbola they are reflected about. So let us now go and sketch the given graphs of hyperbola with the instruction that is given there that we must sketch them. Okay. The first graph that we are going to sketch is f of x is equals to 1 over x. The value of a is positive, therefore the graph is found in the first quadrant and the third quadrant. I'm going to sketch the graphs of the hyperbola f of x is equal to 1 over x. So since the value of a is positive, it means the graph is found in the first quadrant and the third quadrant. So the graph goes like that. So this is the graph, and the other piece is found in the third quadrant. So this is the graph y is equal to 1 over x. You can just pick a point here and say x is 2. Therefore, if x is 2, then y is 1 over 2. And then I'm now going to draw the other graph. The other graph, it is g of x. So this graph here is called f. The other graph is g of x is equal to negative 2 over x plus 1. and negative 2x, negative 2 over x plus 1, that value of a is negative. It means the graph has its value of a negative. Therefore, the graph is found in the second quadrant and the fourth quadrant. So the graph will be found in the second quadrant and the fourth quadrant. I'm drawing this graph in with the dotted line because it is not the graph that I'm being asked to sketch. This is only negative 2 over x. Now this graph has to be shifted 1 unit up. So that means everything about this graph get to be shifted 1 unit up. The asymptotes are shifted 1 unit up. The reflection lines are shifted 1 unit up. So I'm going to start here with the horizontal asymptote. The horizontal asymptote was the line y is equals to 0. Now it is the line y is equals to 1. This is the new horizontal asymptote. Then this graph get to be shifted 1 unit up. So the black graph get to be shifted 1 unit up. So the graph will look like that. And the other piece at the bottom here is also shifted 1 unit up. So the graph is going to cross the x-axis and it looks like that. Now we need to find the x-intercept here where the graph intersects with the x-axis. Now we know that the equation of this line is the line y is equals to 0. The equation of this line here is the line x is equals to 0. So we simply replace y with 0 in the function and solve for x. So this is 0 is equals to negative 2 over x plus 1. I take this negative 2 over x. On the other side, I've got 2 over x is equals to 1. Therefore, x is equals to 2. So the value of x here is 2. So the graph, it is drawn. Then you can identify one point on the graph. If I identify a point on the graph, suppose I pick a point here, the value of x is 1. Now take 1, plug in the equation, therefore y will be negative 1. So that will be negative, it is negative 2 plus 1, that will give us negative 1. So this is 2 and is 1 and negative 1. So that will be the coordinate of that point. Now, let us go and look at the last column. The last column has the function of, is the graphs of the exponential graphs. The standard forms that are given there is a to the exponent x. So we say when a is greater than 1, we have a growth function. And when a is a number between 1 and 0, which is a proper fraction, we've got a graph of decay. Now, various standard forms exist with exponential graphs because now here a is given as a coefficient and the base of the graph is b. And therefore, this q here also constitute the vertical shift, and the c here up here, it constitutes the horizontal shift. So we're going to look at that just now. Let us start by sketching the graphs below. So the first graph that is given to us is y is equals to f of x is equals to 2. So the function's name is f. So it's y is equal to 2 to exponent x. These exponential graphs, they only have the horizontal asymptote. So these graphs, they have horizontal asymptote. The asymptote of the exponential graph is the line y is equals to 0. So the graphs, the exponential graphs, they can get closer to this line, but they should not go through it. So since the value of a is positive, the graph is an increasing graph. It goes like that. Where it crosses here, the value of y is 1 because you simply replace x with 0. 2 to the exponent 0 is 1. But then when you look at the next graph, h of x is equal to 2 times 2 to the exponent x. So this is 2 times 2 to the exponent x. Is this graph, but it has been vertically stretched by that parameter here, the value of a is 2. So that simply means that every value in this graph will be multiplied by 2. So if I come to this point here is 0 and 1, multiply this point, the value of y by 2, it will be 2. So the graph will be vertically stretched like that. So this is the graph of h, this is the graph of f. The other one, we've got 3 times 2 to exponent x. It's the same graph that has been stretched by 3 units but shifted 1 unit down. So you will multiply this one by 3, so it goes there, and then you shift it 1 unit down, it therefore go back to 2. So that graph will go like that because of its vertical stretch. So that will be the shape of the graph. Now this is the basic revision that the learners need to go through before we can move on with the grade 12 functions. Now here they were just revising how to sketch the functions. Let us look at the second worksheet. In this worksheet, they are expected to find the equations of these graphs. Now, what they need to remember, it is the algebraic standard form of these functions. So, if the child does not have that strong relationship in his or her brain, cannot relate the graphical picture and the algebraic view of the graph, then the child will not be able to solve the questions that requires that they find the equation. Now, I know this will be the easiest one, the column 1, which is the straight line. We're going to start by finding the equation of the straight line f. So you simply write, since the graph, I can see it passes through the origin, therefore the equation is y is equals to mx, or y is equals to ax. And from there, I take that point, I substitute. So y is 3, this is m into x is 2. Therefore, I make m the subject. Therefore, m is equals to 3 over 2. So the equation of this line is the line y is equals to 3 over 2 x. So with the name f, is f of x is equals to 3 over 2x. So that is what they are expected to do. Now the other graph, there is a number that is missing here. So this point here, the value of x is 3. Now, I can see the graph is not passing through the origin. So if the graph is not passing through the origin, it takes the standard form of y is equals to mx plus c. That simply means that the graph has been either vertically shifted or horizontally shifted. So we're going to write it like that as y is equals to mx plus c. But when I look at this graph, none of the information here that is given talks about the y-intercept. So we don't have that y-intercept, but we have at least 2 points that we can use to find the gradient and find the y-intercept. So I'm simply going to substitute the first point. We can decide to find the gradient. So the gradient is change in y over change in x. So this will be change in y over change in x. So I'm going to take this point here as my first point and that point here as a second point. So this will be 4 minus 0 divided by negative 1, negative 1 minus 3. So this is 4 over negative 4 and the answer is negative 1. So we can see that the graph is decreasing, hence it has the gradient of a negative number. So the gradient of this line is negative 1. Now, since we have the gradient of negative 1, we can now go into the equation y is equals to mx plus c and replace m with negative 1. That would be negative x plus c. Now we need to find c. We can substitute any of the point between this point here and point D up there. Any of those will work. So I'll take this one since the other value is 0. So I simply say 0 is equals to negative 3 plus c. Therefore, c is equals to 3. So the equation of that line will then be negative x plus 3. So that is the equation of that line. The column of the parabola requires that we find the equations of those parabola graphs. Firstly, the first graph that appears here, I can see the graph is sitting at the origin. Therefore, it takes the standard form of y is equals to ax squared. And we're given a point here, which is 3 and 2. I simply take that 2 point and substitute in the equation. So this is 2 is equals to a times 3 squared. 3 squared is 9, therefore a is equals to 2 over 9. Therefore, the equation of this graph is y is equals to 2 over 9 x squared. So this is the equation of the graph. Now, let's go and look at the other graphs just below the first one. If you look at the graph of h, this graph here, the name is h is given there. We are given the coordinate of the turning point here is negative 2 and negative 3. And then the graph also passes through the y-intercept where x is 0 and y is negative 1. Now this takes the standard form of y is equals to a into x minus p squared plus or minus q. Then we just need to take the coordinate of the turning point and put them in. So this is a into x. The value is negative 2. So that will be plus 2 squared and then minus 3. We just need to find the value of a. So how do we find the value of a? Find any point on the graph and plug it in. The other point we have is 0 and negative 1. So this will be, I'm just going to use the space here. So this is negative 1 is equals to a into 0 plus 2, that is 2 squared minus 3. This negative 3 goes the other way. We've got 4a is equals to 2 squared is 4. 4a is equals to 2. Therefore, a is equals to 2 over 4, which is 1 over 2. So a is equals to 1 over 2. Therefore, the equation of h of x will therefore be 1 over 2 into x plus 2 squared minus 3. So this is the equation of that graph, the graph of h. So this is the equation of the graph of h. The other graph that is given to us, it is the graph of, the name of this graph, I cannot see. Well, I think I forgot to give the graph the name. This graph does not have a name. It has the x-intercept here and the x-intercept here and the point there. So for us to find the equation of this graph, we can use the equation of the graph that talks about the x-intercept. So that graph is, so if you remember, one of the equations of parabola is a into x minus x1 times x minus x2. And we said the x1 and x2, they are the x-intercept. So this graph will be a into x minus x1, this is negative 1, so it will be x plus 1, and x minus, this is plus 4, so that will be x minus 4. All we need is another point to substitute so we can solve for a. And the other point we have here is negative 2 and 3. So this will be 3 is equals to a into negative 2 plus 1 times negative 2 minus 4. So this is 3 is equals to a into negative 2 plus 1, that's negative 1, times negative 2, negative 4 is negative 6. So that will give us positive 6. Therefore, a is equals to 3 over 6, which is 1 over 2. So the value of a is 1 over 2. Therefore, the equation of this graph will therefore be y is equals to 1 over 2 into x plus 1 times x minus 4. And then you can simplify that graph into the standard form of ax squared plus bx plus c, depending on the nature of the question, whether you were asked to do that. Now let's quickly move to the rational function. When we look at these rational functions, they say determine the equation of the graphs below. Looking at this graph, the first graph here, I can see that the graph has its two pieces in the first quadrant and the third quadrant. And this graph, it is asymptotic by the x-axis and the y-axis. Therefore, this graph takes the standard form of y is equal to a over x, and the value of a is positive. So I simply take that point and substitute. So this is 1 is equals to a over 3, therefore a is equals to 3. So the equation of this graph is the function y is equals to 3 over x. So that will be the equation of the graph. This is a grade 10 graph. Second graph at the bottom here, it has been shifted 1 unit to the left. So this takes the standard form of y is equals to a over x minus p. So it has only been shifted to the left. So this will be y is equals to a over, that is minus 1, so it will be x plus 1. For us to find a, we need any other point to plug in here and solve for a. So this will be, so the point is there, be negative 3 is equals to a over 1, therefore a is equals to negative 3. So the equation of this graph is y is equals to negative 3 over x plus 1. So this is the equation of that graph. You look at the exponential graph, they say determine the equation of the graph below. So this graph takes the standard form of a to the exponent x. Now you simply take that point and plug in. So this will be 0.5, which is 1 over 2, is equals to a to the exponent negative 1. So in other words, we've got 1 over 2 is equal to 1 over a, therefore a is equals to 2. So this graph is the line graph y is equals to 2 to the exponent x. Now, let us look at the one below. We have the first one here. It is the exponential graph with the value of a that is smaller than 1 but bigger than 0. So this is the graph of decay, and it has been shifted some units up, and the value of the asymptote is not given there. So this graph takes the form of a to the exponent x plus or minus q. Unfortunately, the value of q is not given, so I won't be able to find the completed equation. When we look at the one at the bottom, it is the exponential graph that it was a growth function has been reflected about the x-axis. So that will simply be the growth part of it goes like that. So this will be y is equals to a to exponent x. And therefore, when it gets reflected, it changes. So the coordinate of this point here will be negative 1 and half. So this is 1 over 2 is equal to a to exponent negative 1, which is 1 over 2. So a is equal to 2. So y is equals to 2 to exponent x. When you reflect it about the y-axis, it becomes y is equals to negative 2 to the exponent x. So this is just the work that the learners did in grade 11 downwards, all the way to grade 8. So this revision is very important. Now, if you check these other questions in worksheet number 3, so basically here, I put some questions that are not necessarily of the very lower grade. Include grade 11, grade 10, and grade 8 and 9. So these are the straight lines. these are the parabolas. So you simply ask the learners to sketch the graphs and you do the corrections with them. Now, at the bottom here, I was giving them questions that are based on the graphs that they were given. If you look at the first one, it says, consider worksheet number 2, column number 3. Write down the equations of the asymptote. So let's go to worksheet number 2, column number 3. What are the equations of the asymptote of the first graph? The equation of asymptote is the line y is equals to 0. So this is the line y is equals to 0. Then write down the equations of asymptote in sketch number 1, and there is no vertical asymptote. Sketch number 2, if you look at the sketch number 2, the first one, remember I said the value was not given and I could not read it from the graph. The second one, the asymptote that is given, it is the line y is equals to 0, and there's no vertical asymptote. It's exponential graph. You go to the second column that is based on the properties of functions. They say consider worksheet number 2, column 2. Write down the equations of symmetry in sketch B. In sketch B, write down the equations of symmetry. Column number 2, the equation of symmetry. The first x is equal to 0, x is equal to 0, and then here is x is equal to -2, and x is equal to -2. When you go to the last column, they say consider worksheet number 2, column 3. Write down the equations of asymptote in sketch number 3. Consider worksheet number 2, column number 3. Here is column number 3. That is about the hyperbola. They say we must write the equations of asymptote. With the first graph, the asymptote, it is the set of x's. With the second one, the asymptote is x is equal to -1 and y is equal to 0. So we're looking, consider worksheet number 2 in column number 4, the exponential graph. Write down the equation of asymptote. The equation of asymptote is the line y is equals to 0. In both of them is y is equals to 0. There is no vertical asymptote.